Good morning, guys. It's Miss Wesley. I was thinking it would be a good idea to go over one of the questions from the HQ for today, which is HQ41E, and it's the second question. It's a little bit trickier of a question, and it's really good preparation for the type of question that you might see on your indefinite integrals quiz. So let's get to it. The first tricky part, I think, is the wording of the question. It says, find the particular solution. So we want to find a solution that would satisfy this term, the differential equation and the initial conditions. What they mean by differential equation, it's an equation in terms of a derivative. So here you've got to go 2 steps backwards. You're given a second derivative, you're given an initial condition about a first derivative, and an initial condition about regular f of x, and you want to integrate. You want to take an antiderivative twice, 2 times, so you can get backwards to f of x. So start with your second derivative and let's turn it into a first derivative. Let's take an antiderivative so that we're just 1 step back to f prime of x by integrating x to the -3/2 with respect to x. That's step 1. And this will be an indefinite integral, and there will be a plus c in the expression that we write, and we'll use these guys to get the plus c in a later step. So first, time to integrate. I'm going to go up a power from -3/2. So add 1 to that to get -1/2. You're dividing by -1/2, right? As long as you raise this to the -1/2 power. And there's an indefinite plus c at the end. This is f prime of x because we've just taken one antiderivative. And we can simplify it a little bit. F prime of x equals -2 x to the -1/2 plus c. So we're looking at this, and first order of business is to try and get c. Use this first initial condition. We know that the derivative, when x is 4, equals the number 7. That's perfect. We can plug in 7 for the derivative, and we can plug in 4 where we see x, like that. Okay. Feel free to use a calculator to help make this a little bit quicker. Otherwise, we can put 7 equals -2. Now think, what would a -1/2 power do to a base of 4? It would flip it and square root it. It's going to turn it into a 1/2, like that. And you get 7 equals -1 plus c, making your first constant of integration. Some books call that c sub 1. We'll just call it the first c, and it equals 8 in that antiderivative. All right, so that is half of the process. That's getting from a second derivative down to a first derivative. Let's write what that actually is. It'll be f prime of x equals -2x to the -1/2 and plus 8. Okay, so we're getting there. Next step, we need one more antiderivative to get backwards to regular f of x. So this is your original function f of x being the antiderivative or the indefinite integral of -2x to the -1/2 plus 8. So we just do this again. We're taking that with respect to x. Time to integrate. F of x equals, well, leave the constant, so -2 is going to stay. Think of the power that x will be raised to, which is 1 more than -1/2, so x to the +1/2, as long as we divide by +1/2, just like multiplying by 2, but I'll write it as 1/1/2. And there's an 8 there, so plus 8x if we take an integral, and then plus your next constant of integration. And we'll try to solve, well, I guess simplify a little bit, right? F of x equals -2, this should just be a 2, we said, so times 2, x to the 1/2 plus 8x plus c. And then we'll simplify a little more, so f of x, almost there, is -4x to the 1/2 plus 8x plus c. And our last job is to find c, and it shouldn't be too bad. At the very top, we were given that f of 0 equals 0. It's time to use that initial condition here. So we can plug in 0 for f of x and 0 for all the x's. -4 times 0 to the 1/2 plus 8 times 0 plus c. So your final c is going to be 0. And then the answer you can submit to WebAssign would be f of x equals -4, you could say square root of x or x to the 1/2, however you want to type that in, plus 8x plus 0. So we can leave off that constant of integration. I hope that helped. Keep the questions coming, and I hope you guys are having a nice day.